Bismillahirrahmanirrahim. Hello and welcome to Dr. Saqib Khan Science Academy. Today we will learn about point of zero charge, how to measure the point of zero charge experimentally, and then how to plot the point of zero charge and measure the point of zero charge from the experimental data. Point of zero charge are also known as isoelectric point. Iso means same. The point at which the charges on the surface of material become zero. It is property of a material or any surface where it has no net charges, no net surface charges. When the charges on the surface becomes equal to zero, then that point is called as point of zero charge. The point at which the surface of any material becomes electrically neutral. This means that it has equal number of positive charges and negative charges. Then we called that point as point of zero charge. It is an important parameter in environmental sciences and in chemistry that we determine the point of zero charge for our adsorbent or our nanomaterial, so we can fully understand or we can fully design our experiment according to the property of our material. There are different methods to measure the point of zero charge. Today in this video, I'll share you the salt addition method. For the salt addition method, the salt which we will use is sodium chloride NaCl 0.1 molar NaCl solution. If you don't know how to prepare 0.1 molar solution, you can weigh approximately 2.922 grams of NaCl and then you can add it to 500 ml distilled water. After this, we will take 11 different flasks and labeled them with as pH 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. You can reduce the number of flasks by changing the pH from 2, 4, 6, 8, 10, 12 like this or as you wish. But when I did the experiment, I took all the pH values for more accurate result. Then we will add 30 ml of 0.1 molar solution to each of these flasks and adjust the pH of these flasks according to their labeling. So for pH 2, we will adjust the pH at pH 2. For pH 3, we will adjust the pH at pH 3 and same goes to pH 12. After adjusting the pH, we will add 30 milligram of our adsorbent of our nanomaterial to each of the flasks. Then we will agitate these flasks in shaking incubator. Normally we run it at 150 RPM revolution per minute for 24 hours. And then after 24 hours, we will filter this out and the filtrate collected, we will measure the pH of our filtrate. Then we will calculate delta pH. Initial pH, which we already know, the final pH of each flask. For pH 2, for example, initial pH is our pH 2. If the final pH is increased or decreased, so we will write that pH. So delta pH we will calculate and then we will plot it. Let's go to the Excel sheet and see the results and how to plot delta pH. This is the initial pH of our flasks 2, 3 up to 12 and this was the final pH after 24 hours of experiment. Now we will calculate the delta pH is equal to, as the formula says, initial pH minus final pH or after 24 hours. So this is our delta pH. We'll copy this data till the end. And now we'll plot a graph. So from here, our initial pH will be on x-axis, while delta pH will be on y-axis. So we'll go to the insert chart menu. We'll select the line scattered plot. So from here, now we will calculate the point of zero charge. Point of zero charge is basically the point from where it crosses the x-axis, where it crosses the x-axis. So we'll adjust this and major unit we can change it as 1 and this one also 0.1. Okay, now we'll go to the tick mark and minor is outside and major outside. Then from here, we'll select the color of the line as black and increase the size of our graph to get more real picture. So you can see over here that it crosses at 5.7, 5.6 or 5.7. It crosses the x-axis at 5.7. So our PZC value or point of zero charge value is 5.7. So at this pH, at the pH of 5.7, our material will have zero charge on its surface. Now, as we calculated the PZC value, and we know that at pH 5.7, if the solution pH is 5.7, then there will be no charges on the surface of our adsorbent. But if the pH is higher or pH is lower, what type of charge will be on the surface of your adsorbent? If the pH of the solution is less than the PZC value, if we put our adsorbent in a solution or in a dye solution or in a metal solution whose pH is less than the PZC value, then there will be more positive charges. Then there will be more positive charges on the surface of our adsorbent. But if the pH of our solution is higher than the PZC value, then the charges on the surface of our adsorbent will be negative. More positive charges will be attracted towards the surface, towards our nanomaterial. Hopefully you understand this. If there is still any problem, you can tell me in the comment section. I'll try to explain it in more detail. Thank you very much. If you got some information from this video, then please like, share and subscribe to my channel. Thank you and Allah Hafiz.